Bismillahirrahmanirrahim. Today's the lecture is the remaining reduction formulas for any trigonometric function. So, which is cosecant power n of x with respect to x. This is the today function, and we will find its reduction formula. So we will split this as we split the previous functions, which is secant of x, cosine, sine and cos. Now we will split this function also, which is integratable. So first of all we can write, let this function is equal to I n, and we will find its reduction formula. So let this function is equal to in. Let's suppose this function is equal to in. So we can write this cosecant power n of x is equal to cosecant power n minus 2 of x and cosecant square of x. We can write this functions as a product of these two functions. So these functions are equal. This side is equal to this side. So we will substitute cosecant power n minus 2 of x, cosecant square of x here in the place of cosecant power n of x. So in is equal to integral. In is equal to integral of cosecant power n of x with respect to x dx. So integral of, substitute these values, this and this here in the place of cosecant power n of x. So integral of cosecant power n minus 2 of x with cosecant square of x dx. Now this is first function and this is second function. We will apply again the integration by parts formula on these two functions. So in and its place, so it is first function, integration by parts using integration by parts formula. So first function, integral of second function, which is cosecant square of x. So first function, integral of second function, minus whole integral of derivative of first function, which is first function is cosecant n minus 2 of x. First derivative of first function and integral of second function, which is cosecant square of x. This is the applied integration by parts formula. So we will proceed these functions. So this is first function, this is first function and this is second function. So in is equal to first function cosecant of n minus 2 of x and integral of cosecant square of x. What is the integral of this? So we know that derivative of cotangent of x is equal to minus cosecant square of x. So integral of cosecant square of x is minus cotangent of x, because differentiation and integrations are reverse of each other. So if derivative of cotangent x is minus cosecant square of x, then the integration of cosecant square of x is equal to minus cotangent of x. So integral of cosecant square of x is dx is equal to minus cotangent of x. So first function, integral of second function, minus whole integral derivative of this function. So derivative of this function n minus 2, this n minus 2 will be decreased by 1, so it will be equal to n minus 3 of x, n minus 2 cosecant power n minus 3 of x. And again derivative of cosecant x by extended power rule is minus cosecant x and cotangent x, and integral of cosecant square of x is cotangent minus cotangent x, which is multiply with this minus will be plus, so it will be equal to cotangent of x with respect to x dx. So it is much complicated steps, because here is in the differentiation and integration involve minus with these two functions. So we will proceed these steps. So in is equal to cosecant of n minus 2 of x minus, we can write this minus will here, and cotangent of x minus n minus 2 will be out from this integral, with integral cosecant power n minus 3 of x multiply with this cosecant power 1 of x, which is basis same power will be added, so n minus 3 plus 1 will be equal to n minus 2, so cosecant power n minus 2, and cotangent x with cotangent x is cotangent square of x dx. Now we know that Pythagorean formula that 1 plus cotangent square of x is equal to cosecant square of x. So shift this one to this side, so it is equal to cotangent square of x is equal to cosecant square of x minus 1. So substitute cosecant square of x minus 1 in the place of this cotangent square of x. So n is equal to minus cosecant n minus 2 of x with cotangent of x minus n minus 2 is out from this integral, so it is cosecant of n minus 2 of x, and cotangent square of x is equal to cosecant square of x minus 1, cosecant square of x minus 1. So this side is equal to in, so in is equal to cosecant of n minus 2 of x with cotangent of x minus n minus 2, and multiply this function with each other, so it is equal to integral of cosecant of n minus 2 with 2, it is cosecant of n of x minus cosecant of n minus 2 of x dx. These functions have been multiplied with each other, so in is equal to minus cosecant of n minus 2 of x with cotangent of x minus n minus 2. Multiply these n minus 2 to these two functions and apply integration as well to these two functions. Integration applied because linearity rule of integration. So n minus 2 integral of cosecant of n of x dx minus with this minus is plus, so n minus 2 integral of cosecant power n minus 2 of x with respect to x. This is the function, so it is equal to in minus cosecant of n minus 2 of x with cotangent of x, and this function is equal to in, so minus n minus 2 with in plus n minus 2 with integral of cosecant power n minus 2 of x dx. So shift this term to this side, so in this will change to plus n minus 2 in, which is equal to minus cosecant n minus 2 of x into cotangent of x plus n minus 2 with integral of cosecant of n minus 2 of x with respect to x. So common in from this function, so 1 plus n minus 2, which is equal to minus cosecant of n minus 2 of x, cotangent of x plus n minus 2, this is n minus 2. So in 1 minus 2 is minus 1, so it is n minus 1 is equal to minus cosecant n minus 2 of x, cotangent of x plus n minus 2 with n minus 2, dividing n minus 1 on both sides. So n is equal to minus 1 over n minus 1 with cosecant, this is minus 1, cosecant of n minus 2 of x into cotangent of x plus n minus 2 divided by n minus 1 with n minus 2. This is the reduction formula. So reduction formula of cosecant power n of x with respect to x is equal to in minus cosecant power n minus 2 of x divided by n minus 1 with cotangent of x plus n minus 2 divided by n minus 1 with n minus 2. So if you guys are like the video, then please share it with your friends, and you have any question in this lecture, then you can ask me in the comment section. So thank you.